Hello Year 11, this lesson is going to be on solving equations with unknowns on one side. Now this is revision for you, so what I would like you to do is pause the video and have a go at solving the four equations that you can see on the screen. Okay, so the focus here is on inverse operations, so thinking about what has happened to x and then undoing those things in reverse order. So this first one here, we've multiplied x by 3 and we have added 5. So we're now going to reverse those things. We're going to subtract 5 from both sides, which will give me 3x is equal to 21. And then we're going to divide by 3, which gives me x is equal to 7. Now it's really important that you focus on how you are communicating what you've done. So look at these workings here. This is telling the examiner exactly what my thought process was and will allow me to get marks even if I make a little mistake in my arithmetic. Okay, so moving on to the next example. Here we've got 9 add 4x is equal to 33. And this would be exactly the same as if I'd written 4x add 9. So I'm still going to think of this as having added 9 to 4x, and I'm going to now reverse that. So I'm going to subtract 9 from both sides, which gives me 4x is equal to 24. And then I'm going to divide by 4, which gives me x is equal to 6. So don't worry about things looking like they're back to front, because it is actually exactly equivalent to what we had above. Okay, so moving on to the third example, here we've had x multiplied by 5 and then we've subtracted 2. So this time we're going to reverse that by adding 2 to both sides, which gives me 5x is equal to 10. And then I'm going to divide both sides by 5, so x is equal to 2. And again, underneath this one, we've got something that looks a little bit different to normal because we've got the x on the right-hand side, but this is exactly the same as saying 3x subtract 8 is equal to 13. So if you prefer, you can actually switch those around if you prefer to look at it like that. But I'm going to add 8 to both sides. So 21 is equal to 3x, and then I'm going to divide by 3. So it says 7 equals x, and I'd rather see that presented the other way around as x is equal to 7. So I can just switch that around at the end. Okay, moving on then, you could have situations where you have brackets to expand before you solve your equation. So that just adds an additional step to your working. Again, this should just be revision. So what I'd like you to do is pause the video here and have a go at solving these yourself first of all. Okay, so what we're going to do is expand the brackets first of all. So 3 lots of 2x is 6x, add 3 lots of 7, which is 21, and that is obviously still equal to 25. And now these look like the equations that we were solving before. So we're going to subtract 21 from both sides, and that gives me 6x is equal to 4. And so the next step is to divide 3 by 6, but now we've got something awkward. We've got to do 4 divided by 6. So the key to solving these equations where the numbers are a little bit awkward is just to write your answer as a fraction. So 4 divided by 6, we can write that as 4 over 6. And now we have an answer which we can be given marks for, but you can simplify that. So 4/6 is the same as 2/3. And that's my answer. I don't need to necessarily write that as a decimal. In fact, it looks nicer and neater as a fraction. Okay, so the next example, I'm going to first expand my bracket, and that's going to give me 10x subtract 20. And so now I'm going to reverse the subtract 20 by adding 20 to both sides, which gives me, that should say 33 is equal to 10x, not 23. And again, that number is going to be a little bit awkward. I'm going to have to divide 33 by 10. Now that's a little easier to do, but again, I can write it as a fraction. Again, that should say 33 over 10. And if I like here, I can write that as a decimal. And of course, it should be there 3.3, not 2.3. Okay, so here are some examples for you to try. These do get really, really challenging in the green section of this work here, but the principles all remain the same. So what I would like you to do is pause the video and have a go at solving these equations, and then I will upload the answers to these tomorrow.